This is a presentation about routing decision. It's a part of my CCNA2 course. When a router receives a packet, it will unpack it until layer 3 because the router needs to look at the IP address to find out where to send it. When it has looked at the IP address, it will look at in its routing table and find out what to do with the packet. And then it will pack it in again and send it on to the next router, which again will unpack it up until layer 3, look at the sender's or the receiver's IP address, look into its routing table, find out what to do, pack it in again, and then send it onwards to the next router. So they will encapsulate and de-encapsulate up until layer 3 when we have a router that receives information. So here PC1 wants to send something to PC2. And since PC2 is on another network, it will then send it to the default gateway first. The default gateway here is router 1. So first of all, PC1 will find out what is the MAC address of router 1. Then it will send it to router 1. And router 1 will then look into its routing table when it receives the message, the packet. We'll look at, see what is the destination IP. Well, it's 192.168.410, which is on another network. It will look into its routing table. Do I know this network? Yes, I do. And I will exit it or send it out on fast Ethernet 01. And the next hop IP address is 192.168.22, which is the IP address of router 2 on the combined network between router 1 and router 2. So then it will send it on to router 2. Router 2 receives it. Do the same thing, unpack it up until layer 3. Look into the destination IP address. Look then into its routing table and find out, do I know this network? Yes, I do. And how do I get there? Well, I'll get there by going out of my interface S000, and the next hop address is 192.162.32. And then router 3 will do the same thing. Receive the packet, look up into layer 3, look at the destination IP, find out what to do with it, and then send it on to, in this case, fast Ethernet 00, because this is a directly connected network. And then it's received. So the process here is that it will look into its routing table to find a match and then find it whether it's a directly connected network, if it's a directly connected network that we have, then it will look into its ARP cache, because then it will need the MAC address of the receiving host. Otherwise, if it's a remote network, well, then it will find out what to do. What is the next hop? And if there is none of these two, well, then it will check the third thing, which is if it's a gateway of last resort, whether it's a default network available. So whatever I don't know about, I will send to a specific address. If no, well, then it will drop the packet and say, I don't know what to do with this one. Apart from finding out where to send it, the routers will also try to find the best path. And there are different ways of deciding what is the best path. First of all, if we have a routing protocol, it will create some kind of a metric, and the metric will be the one that decides what is the best path. So the best path is the one with the lower metric. For instance, if we do RIP, the Routing Information Protocol RIP, then it will look at the hop count. Where I'm going to hop the fewest times will be the fastest. It does not look at the bandwidth, it does not look at the connections, it only looks at how many hops do I need to do, how many routers do I need to go through to get there. Whereas the OSPF will look at the bandwidth as well. It will calculate the cost, which includes, among other things, the bandwidth. So it will actually try and find the fastest way through a network. And then we have something called the EIGRP routing protocol, which will look at both bandwidth, but also the delay and the load and reliability of the links as well. So this is how the different routing protocols will try to find out what is the best path. If there are two routes to the same network which has the exact same metric, then the routing protocols will load balance between these two. So at one time it will send it in one direction, the next time the other direction. So it will load them out on both of them. This will of course help the network performance and also the redundancy. So we have two different ways of reaching the same network. If we have more than one routing protocol, then it's of course we cannot compare the metrics. We cannot compare hop count with bandwidth because they're two different things. So here we are using something called the administrative distance. The administrative distance tells us something about the trustworthiness of a route. And the lower the AD, the better the route. So we can see here, for instance, a directly connected route has the lowest administrative distance. This is the most trustworthy route. And then we have the static routes, and then we have some different EIGRP. We can see that OSPF has an AD of 110, whereas RIP has one of 120. So we will prefer using an OSPF route above a RIP route, for instance, because OSPF will also look at the actual bandwidth. So this is just to compare different routing protocols, and that was it. Thank you.